On the left is an outdated UI card resting on a muddy, flat gradient. On the right, we have a multi-layered glassmorphic card sitting over a vibrant mesh gradient. The physical, tactile quality of the card on the right makes the interface feel premium. This technique succeeds by mimicking real-world physics. It simulates how light refracts, diffuses, and creates depth passing through textured, frosted glass. In the next 5 minutes, we are going to build this exact glassmorphic card from scratch using pure CSS. We will do it without relying on heavy frameworks, and we will ensure it meets strict web accessibility and performance standards. Step 1 is setting up your workspace. Open a live preview coding environment and apply a vibrant CSS mesh gradient to your HTML document. That vibrant background is a mandatory foundation. Without a complex, colorful spectrum sitting underneath your elements, the frosted glass has no varying light to refract, and the visual illusion falls flat. We begin by creating our base HTML container. Add a standard div element to your document and place an H2 heading and a paragraph inside it. Looking at our live preview, we immediately encounter an issue. The raw text sits directly on the bright background gradient, making it very difficult to read. To lift that text up, we use Glassmorphism. This requires stacking 4 distinct optical layers. Right now, we only have the foundation, layer 1, our gradient background plane. Next, we drop in layer 2 by applying the CSS property backdrop filter, set to blur. This diffuses the background colors exclusively within the footprint of our container. The third layer is the physical frosting. We set a background color using an RGBA value with low opacity. This adds a subtle white tint over the blurred space. Finally, we define the physical edges. By assigning a 1-pixel semi-transparent border and a soft box shadow, we lift the element off the page and give it actual mass. A quick note on the frosting layer. If you use a solid hex code instead of a low alpha value, the background becomes completely opaque and your blur effect will disappear. The depth you see is the result of these 4 specific properties: blur, transparency, border, and shadow, working together in precise alignment to trick the eye. Layered transparency carries a hidden danger. When text shifts over varying background colors, readability often drops to unacceptable levels. This contrast checker displays a failing score for our current layout. The WCAG accessibility standard requires a 4.5:1 contrast ratio for normal text. Semi-transparent backgrounds routinely fail this metric because they inherit the brightness of whatever sits behind them. We fix this with 2 steps. First, we apply a subtle CSS text shadow to the typography. This separates the letter forms from the shifting frosted panel underneath. Second, we adjust the background RGBA opacity value. Moving it from 0.1 up to 0.3 creates a slightly darker or lighter panel directly behind the text, enforcing a higher contrast ratio. With the text legible, we add a border radius. This smooths out the harsh corners of our container, mimicking the polished, rounded edges of physical cut glass. A beautiful interface has 0 value if the user cannot read the text. Validating contrast is a mandatory step in deploying any glassmorphic element. Next, let's insert a new interactive element, a submit button inside our glass container. For this button, apply a solid background color. Avoid stacking glassmorphism on top of glassmorphism, as it reduces the visibility of clickable targets. The backdrop filter property is computationally expensive for the browser to render. To prevent laggy scrolling on lower-end devices, strictly limit your glass elements to 2 or 3 per viewport. Create a clear visual hierarchy. Reserve frosted glass exclusively for large structural containers, like carts and sidebars, and use solid, opaque colors for smaller interactive components. Balancing transparent aesthetic panels with solid functional elements yields an interface that is both highly usable and highly performant. Looking at this mockup, our final glassmorphic card operates perfectly. Notice how it dynamically adapts its tint and shading across 3 entirely different underlying color meshes. We accomplish this using 4 basic CSS properties: backdrop filter for the blur, RGBA for the tint, a transparent border, and a soft box shadow. Now take this exact code block and adapt it for a dark mode interface. Swap your white RGBA values for low opacity black values and check the results in your preview. By mastering these core CSS properties, you have the tools to build premium, future-proof interfaces from scratch, independent of heavy frameworks.